Hello students, I welcome you to this session where we will see how we can create isocircle on inclined plane. So most of us we know that how we can create the isocircle on regular isometric planes. So we should understand the steps of creating an isocircle on inclined plane. So in this particular video I will be explaining those steps, so you can go through those steps and you can use your drawing instruments and sketchbook, and you can create the conventional way of making an isocircle on inclined plane. Okay, of course if we are using any tool like AutoCAD software, we can easily create those isocircle on inclined plane, but what we are learning in this particular video is the conventional method of creating isocircle and on inclined plane. About me, I am Onkar Potadar. I have taught engineering mechanics and engineering drawing for more than 5 years, have total experience of more than 8 years, and have taught important mechanical engineering subjects also. So do follow my YouTube channel and Facebook page for regular updates on latest videos. So let us start. So here is the question. Now in this question, two views are given, front view and right hand side view. Origin is also given. Now I assume that you know some concepts about the isometric projections. Otherwise, this video will not be the direct help. I recommend you to first understand some concepts about isometric projections. Now how to make simple objects. Then you can refer these videos. Okay, this video. So two views are given. Origin is here. So this direction will be the length and this is the width. So all the dimensions are given for this particular question, and our task in this session will be to create this circle. So as you can see, this circle is, if we see from this direction, it is on the inclined plane. So this plane is inclined plane. It is not normal regular iso plane. It is an inclined plane. Okay. So we need to create this part of the circle on this plane. So it is in horizontal position also. That means with the help of a drilling machine, it is drilled in this direction. Okay, and the center of the circle is at a distance of 45 millimeter from this baseline, from the bottommost line. So let us see the first step. So of course we need to create a block as per the given dimensions. Okay, so this diagram we can create from this question. So this length is 80, width is 70, again height is 80 millimeter. So with those dimensions, and this length is 20, with those dimensions we can create this block. So this is 80, this 70, height is again 80. So we can join like this. We can create this block. Now our main task is to create that isocircle on this inclined plane. Okay, so that is our main task. Now you see the next step. Now we need to identify the location of this circle. Now this circle, where is it is located? We need to identify from the vertical direction as well as in the horizontal direction. The center point we have to identify, and also remember the diameter of the circle is 30 mm. So that we will do in the next step. Okay, so this step is over, and in this step we will see the location of the circle. So the circle is located at a distance of 45 millimeter from this position. Okay, from this position it is located at a distance of 45 mm from the bottommost position. Then we will draw one line like this. From the midpoint of this line to the midpoint of this line, we will draw one line. This line indicates, it is on the inclined plane. Okay, that means on this line we have the center of the circle. That you have to understand. Okay, on this line we have the center of the circle which we have to draw here, isocircle. Okay, and along the vertical direction it is at a distance of 45 mm. You can see this dimension, right? Now in this step, what you can do is you can take the drawing instruments and a sketchbook. You can read, you can create this particular diagram. Okay, whatever I am explaining, you can pause this video and you can create those steps, right? So what you will be doing is, from here you create one line 45 millimeter. Why 45? Just I told, because it is lying at a distance of 45 millimeter from the base. Then from this point you draw one line. Now this line is isometric line, this line is parallel to this line. It is parallel to this line, isometric line, 30-degree line. Okay, so that it will intersect this inclined plane line. It will intersect this line. So you can draw like this. You just extend it, whatever may be the length, extend it so that it will cross through this. So we will get this particular point, the intersection point. Now it is the center of the circle on this inclined plane. That is the center of the circle. Okay. I will later explain the practical aspect of this. Actually, we are trying to create the shadow of this center on the inclined plane. The shadow of this point, which is the center of the circle on this inclined plane. Therefore, we get that center. Okay. Now the next step is, now since the diameter of the circle is given in the question as 30 mm. So radius is 15. So what we will do is, from this position which we had at a distance of 45 millimeter, okay, we had that at 45 mm. From here we will draw another line in the vertical direction, 15 millimeter upward and 15 millimeter downward. It is shown here 15 mm and 15 mm from the center of the circle, upward and downward. That will be our next step. And from those points again we will draw parallel lines. That means 30-degree lines parallel to this line, okay, isometric lines, so that they will intersect this middle line. So this line is on inclined plane. So this will be our next step. Okay, so again you can pause this video and you can create those things. Now you see, we will create this circle. Of course I had created that here. I will explain it. Now we will create one small circle. A circle anywhere, wherever space is available. Now the diameter of the circle should be equal to the diameter of circle what we are, it is given in the question. It is 30 diameter. This should be of 30 diameter only. After creating the circle, we will draw one horizontal line and vertical line as the center lines. These are the steps you have to follow. Then we will divide this circle into equal number of, not equal number of parts, but some number of parts we will divide. Okay, so we will be dividing these circles in the horizontal direction, the way it is done here. Okay, so my suggestion is that you can keep this gap a constant gap, so that it looks good, decent it looks. Okay, so what I have done is I have kept a 2 millimeter gap between these lines. So at a distance of 2 millimeter I have drawn these horizontal lines, and that way we have done the divisions. So start from the center line, don't start from here, start from the center line, 2 millimeter, 2 millimeter, 2 millimeter, 2 millimeter, like this you draw in the vertical also, and here also, this part also. So entire circle is divided. So that way you create this step. Okay, then after this we have created those divisions on the circle. Now same number of divisions with same gap we have to create on this line also. Now what is this line? This line is the 15 millimeter here. This is 15 millimeter and this is 15 millimeter. So this is the center, which is at a distance of 45 mm from the base. Okay, you can see here in the previous step we have 15 and 15. So this entire 30 from this point to this point, this 30 will be divided into same number of parts as we have done for the circle. So what you can do is, if you have done it for equal dimension, that is 2 millimeter, you can also measure 2 mm, 2 mm, 2 mm here. Otherwise you can take compass, measure this width, this gap you measure, and you just put those gap here. Okay, so ultimately we have to divide this line also. Okay, I hope you are understanding. So divide this line also into same number of parts as you have done for the circle. Now once we have these divisions on this 30 mm line, where this is the center of that, okay, then in the next step we will project those points on the inclined plane. Actually we will try to get the shadow of all those points on this inclined plane. Okay, so how do we project? That means from these points we will draw parallel lines. That means isometric lines, 30-degree lines. All these lines, white color lines, are parallel to this line. They are parallel to this line, and they are projected up to inclined plane, up to this line. Okay, that is the next step. And also you mark these divisions just for better understanding. So this is the center line C, give the notation, and these are the divisions 1 2 3 4 5 6 7. You can make any number of divisions. More the divisions, more will be our accurate curve, but it will take time. So less means we can finish early, but again the accuracy won't be better. Here also you give these notations, either you can give ABCD or 1 2 3. Okay, so we have done in 7 divisions. So this is the step that we have seen now. In the next step, you see, this is the next step. So now the diagram is becoming more complex. Okay, so these are the steps actually we have to follow. We don't have any other option in the conventional method. Okay, what we had seen in the previous step, we have drawn these projections on this inclined plane up to here. Now we are getting these intersection points. These points we are getting on the inclined line or on the inclined plane. We have this point, we have this point, we have this point, we have these points. So from those points we will be drawing parallel lines like this. You can see from those points we have drawn those parallel lines from those points. Now these parallel lines means what? They are again isometric lines which are parallel to this, or 30-degree lines in this direction, that is along the width. Along the width the direction we will be drawing those parallel lines from these points. So that is the next step. Okay, now we are no, our work is almost over. Also make sure that you give notations. Okay, so this is our center line. You can see this is the center line which is coming from the midpoint. Okay, it is coming from the midpoint. So these are the points, divisions 1 2 3 4 5 6 7. Here also you give these notations. Now the next step which I will show is that I have already created this isocircle. That means how are we getting this curvature on this inclined plane? So this is actually the solution, the final solution. But how to draw this, that I will explain. Now you see, now we have this center line C. We also have the center line on inclined plane also, right? We need to compare them. That means you take the compass, from with the help of compass you measure this distance from here to here. So that compass radius you take, and that length you have to cut from this point on both the sides. So of course it will be 15 and 15 because it is a center line. It will be 15 and 15. So from this point you cut on both the sides. So you will get 2 points here on this line, and go to the next line, line number 1, either this line or this line. Again you take compass, keep the compass point here, you measure this distance. Either you measure left or right, it is same. It is a circle only, it is same. So you measure this distance, you take that compass distance and go to line 1, keep the compass here and cut on both the sides for line 1. By keeping compass here, cut on both the sides, and also do it simultaneously here also for this line also. Okay, because it will be symmetric. For this line also you cut on both the sides. You then go to second line, go to the next line, that is second line, take the compass, measure this width, okay, measure this length, then go to second line here, keep the compass here and cut on both the sides for this line as well as for this line also. So like this you have to progress up to 7 line. Now this line is the end point, that is the extreme point. Okay, that means that last point is here. Okay, it is here only, extreme point. Okay, so there is no length like this. Okay, so like this you have to proceed, and you will get various cut points here. You will get an elliptical shape, enlarged elliptical shape, various cut points, and that you have to join. Either if you are good with your freehand sketching, you can draw it freehand. Otherwise you can use the instrument like French curve, and you can create that particular curvature. So that will give the required circle on the inclined plane. It is not perfect isocircle because we are drawing it on the inclined plane. Okay, so you can call it as an enlarged ellipse. So the concept you can see here, that we are actually trying to create this shadow. Now this entire this complete circle is the shadow of a disc like this. We have a disc something like this. It is the shadow of this kind of disk which is kept here. So you can imagine that there is a disk here of like this, and its shadow is falling on this inclined plane. So as this inclined planes becomes you can imagine, visualize that you try to change this angle of inclination, accordingly the length will change, this length will change, but width will remain same. Okay, width will remain same. So you change this inclination, the width will remain same, the width of the shadow will not change, only the length will change. Okay, so if this plane becomes vertical plane, perfect vertical plane, then the length becomes, you can understand, the length becomes equal to the diameter, it becomes 30 mm, and width will also be, then we will get the perfect circle only. Okay, so that is how we have to understand, that is the concept that we have studied in this particular video. So you can pause wherever required, and you can solve it with the help of conventional method. Okay, so in another video I will explain you how we can create a circle where we are having a vertical hole. Now this is horizontal hole, you can see in the question it is the horizontal hole, the vertical hole. Now if it is vertical hole, the final diagram of this circle will be same, it will not be different, but the procedure is a little different. Concept is same, but procedure is a little different. Okay, so that we will see in the next video. So thank you for watching.